look at the program which is used to find the value of x is to y. But this time I'm not supposed to use any library function. I'm supposed to do it mathematically using a for loop. We have a simple power example of x is to y using a math.h header file and a function called as POW. If I say POW x comma y, that will be sufficient to say x is to y. What if they ask you to do a manual function or a manual program which is used to find the value of x is to y? How do I carry out? So let's take a simple example. Assume that your x is given as a 2 and y is given as a 3. I want to find the value of 2 raised to 3. Mathematically, the value of x is to y is multiplying x by itself how many times? Y times. Whenever I ask you to find the value of x is to y, mathematically what we do is we multiply the base by itself again and again till it is multiplied by the power times, that is y times. Most of us, when I say that I have to multiply x by itself, then I might write expression x equal to x asterisk x. But this is not the logical expression which is supposed to be used. This is wrong. This is invalid. Why? What happens in this particular case? Now, if I do it for 3 times, I'm actually destroying the base itself. See here, x is 2. 2 asterisk 2 is what? 4. So now x becomes 4. Next time it is 4 into 4, that is 16. Next time it is 16 into 16, that is 256. The value of a base keeps on destroying if I use this expression. So this is not a valid expression. I'm supposed to now identify a valid example or valid logical expression so that x is multiplied by y times. So for that, what I'll do is, I'll take a loop which will repeat for how many times? Y times at this place. So let's say I as say 1. And I will execute for how many times? Y times, that is I will be 1, 2 and 3. And every time what I'll do is, I'll store this particular base with respect to multiplication accumulation process. So let's take a variable r and set this with 1. R is multiplied by x. So 1 is multiplied by x, 1 becomes 2. Now see, in this case, r gets changed from 1 to 2, but x will not be altered. So I becomes 2. Again take this particular r multiplied by x. So 2 into 2 is 4. When I becomes 3, again take this particular r multiplied with this base, that is 4 into 2 is 8. When I becomes 4, I has crossed the limits of y, stop this particular operation and say r as the result of this particular expression. So basically what I did was, I took a result variable r as 1, kept on multiplying it with x rather than x multiplying by itself. When you multiply r with x, it is as good as multiplying x by itself. So this has to be done for how many times? Y times. So I is 1, 1 less than equal to 3, true. I is 2, 2 less than equal to 3, true. I is 3, 3 less than equal to 3, true. I is 4, stop this particular operation. Let's implement a code of this logic with the value of x is to y. So here I have written a code which is used for implementation the value of x is to y. Now as usual, I have taken I as a loop variable, x and y as 2 variables which indicates base and power. Long int r equals to 1, the result variable. Since the process is with respect to multiplication, your r will be set with 1. Clear the screen, ask the user to enter the base and power. So enter the base and power. So I'll read the base as x and the power as y. Scan of %d, %d, ampersand of x, ampersand of y. Now I said multiply this particular base for how many times? Y times. So y times. So I'll run a loop for y times. So I is going to be 1, I less than equal to y, I plus plus. Every time when I changing its value from 1 to 2, 2 to 3, 3 to 4 till it reaches to y, what you do is, take the result variable, multiply it with x. When you multiply it with x, automatically the result will store the value of x is to y. Let's implement this particular operation. So here, x is say 2, y is say 3, and let's take a result variable as r, initially set with 1. I is also set with initially 1. So now let's start the loop. I is 1, 1 less than equal to 3, true. Multiply r with x and store result back to r. So 1 into 2 is 2. Multiply and equate. After that, I becomes 2, 2 less than equal to 3, true. Take again r, multiply it with x and store result back to r. So 2 into 2 is 4. Again, go back, I plus plus, I becomes 3. 3 less than equals to y, true. Again take this particular r, multiply it with x and store result back to r. So 4 into 2 is 8. When I becomes 4, stop this particular operation and declare percentage d raised to percentage d. First percentage d corresponds to x. X is what? 2. Percentage d raised to 2 raised to percentage d, that is y, that is 3. 2 raised to 3 equals to percentage ld r. R is 8. So I'll say r as 8. So we have implemented the program to find the value of x is to y without using the power library function. So here I'm not used any mathematical function, power function, but still we are able to get the value of x is to y, right? So keep trying these factorial and x is to y. Looks identical, but there is a different logic altogether inside that. Thank you.